over here. So what we need to look at, we've done a lot of graphing lines and stuff. Earlier in the year, we looked at some inequalities. I guess I can't move away from the document camera, though, if I'm going to talk. We're on page 62. What we need to look at are some inequalities that have two variables in them, an x and a y in them. For example, y is less than 2x minus 3. My goal with something like this is to find all points that make the inequality true. My goal, we should be writing some stuff down on page 62, our goal is to find all the points that make it true. My goal, find all points that make the inequality true. In the box, thank you.
Have a good day.
You too. Is 4 comma 0 a solution? Is 4 comma 0 a solution? True. Will it make the inequality true? I want to find all the points that make it true. And first I want to know, is 4 0 a point that makes it true? And well, I don't know, maybe. I can plug in to see what happens. We're going to plug in to check. A solution. Sorry, I'm going to start writing in print. Sorry about that. Well, hold on a moment. We got some work to do. Plug in to check is what we're going to do. Please make sure we're right in front of them. The 4. Where will I plug that in? Oh, for the x and the 0 for the y. So I'm going to get 0 is less than 2 times 4 minus 3. Well, what's 2 times 4? Is 0 less than 5? It is? Sure, 0 is less than 5. That's something that's true. So the answer is yes, 4 comma 0 is one of my solutions. I got a true inequality when I was done. That means 4 comma 0 is a solution. Sometimes I forget things very quickly. So, yes, it is a solution. Sorry about that. I'm going to try harder with the next one. Is negative 2 comma 3 a solution? What do you think you have to do? See if you can do the plug-in. So you're going to go back to that formula. You're going to plug in the negative 2 where the x is and the 3 where the y is and see what happens. Keep that mask over your nose. Now it is. No, I mean, I'm talking about it being a solution. I'm saying now the mask is over his nose. Is it a solution?
Oh.
Okay, one more moment. Well, come on. Let's go. Plug in the -2 for the x, the 3 for the y.
Is it -4 times -3 or is it -4 minus 2?
So this is x. This is y. I'm getting 3 is less than 2 times -2 minus 3. Order of operations says do your multiplication first.
I did it.
A little louder, Jonathan? If the numbers are bigger?
Right.
Okay, so let's finish this. What is -4 minus 3? Is it true that 3 is less than -7? It's not true. 3 is not less than -7. That's false. So let's answer the question now. Is -2, 3 a solution? No. We found one that was a solution, one that's not. The problem is there are like a whole lot of points that are solutions and a whole lot of points that are not solutions. So we need a way to sort of show all the points that are solutions and show all the points that are not solutions. Remember our little number lines that we graphed and we kind of did the arrow that way showing everything that was a solution to that? Well, we've got something similar with our two variable inequalities that we're dealing with here. So here's what we need to do to show our solutions. And we're going to look at the example. Y is less than 2x minus 3. There are many, 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 many points that are solutions, and I want a way to show all of these. EX, example. Danny, can you wait till we're done with the notes? Here's what we're going to do. Number 1, we are going to graph the line. Y equals whatever I gave you. I gave you y is less than 2x minus 3. Let's graph the line y equals instead. However, when we do this, there's a particular way we're going to go about doing this. And I'll explain why in a moment. If our symbol is less than or greater than, we're going to graph using a dashed line. And if instead the symbol is less than or equal to, or greater than or equal to, we are going to use a solid line. If our symbol is less than or greater than, we're going to use a dashed line. If the symbol is less than or equal to or greater than or equal to, we'll use a solid line. When I graph this line, how should I do it? Dashed line or solid line? According to the rules I just wrote on the screen. Dash, because it was just less than, not less than, or equal to. If I put the little line underneath it, we'll do a solid line. We're going to use a dashed line over here. Okay, so remind me how to graph a line. Where do I start? Slope is 2 over 1, up 2, right 1, up 2, right 1, up 2, right 1. Solid or dashed? What did we say? Dash line.
Oh, what? So you have a dash?
You need
Oh, that's cool.
And I'll explain why once we're done with the whole thing. Hello? I'm okay, I think. How are you? I do. Yeah, I will send her down. Yep. Bye. Maddie, you need to head down to the nurse with all of your stuff.
Yo, what you got, Coach?
We have a line that looks like this. I think. I hope. Number 2. Here's the point. This line split my grid into 2 different regions, a region over here and a region over there. All of the points that make the inequality true are in one of these 2 regions. And we're going to shade the region with all the solutions. And I'll explain how to do that in just a moment. We're going to shade the region of the plane that makes the inequality true. Yeah, I need to explain what that means. So let's just write it for right now. Then I'll explain how we figure that out. Shade the region of the plane that makes the inequality true. Please stop, Shane.
Okay.
Shade the region of the plane that makes the inequality true.
Negative or that?
After Danny, let's finish the note.
It's an emergency.
Absolutely. Okay, here we go. Here's what I mean with the shading. If we have less than, doesn't less than mean below? We're going to shade below our line. Sorry, we're going to shade below. Why below? Because it's less than. And if we have greater than or equal to, we're going to shade above because that's greater than. So, well, actually, I'll let you keep writing. That was supposed to be on the side of the room, Jane.
I don't feel. I need to know if my mom got it.
No, you don't.
Yes.
This was a less than problem, which means according to my rules, I need to shade the region below the line. Let's find the y-intercept of our line. Right over here, right? I want to shade everything under it. Over here, over there, anything below your line. And the point is that everything in this shaded region is included in our solution. Every single point that just got shaded would have made the inequality true.
Can I just like do a squiggly line?
Make it look nice. I don't know. I don't really know. That looks wonderful, yes. That's what I'm looking for. Now, so the whole point of the shading is we just showed all the points that make this thing true. The reason for the dashed line is because if points are on the dashed line, They're not quite going to make it true. If it was a solid line, the points on the solid line would have made it true. But because it's dashed, won't quite make it true. We need to do a few of these, and then we're going to do a little bit of practice. What part don't you get? Go quickly, Danny. Sign out.
So if it's going this way, they're shading the top?
If I have a less than problem, I'm going to shade underneath it. If I have a greater than, I'm going to shade above it. If I have just less than or greater than, I'm going to use a dashed line. If I have less than or equal to or greater than or equal to, I'm going to use a solid line when I do it. So I need to show you a bunch more examples of this, and I think if we see a few more, we're going to pick up on what's happening. Question, Shane?
Is that greater than or less than?
This looks like a less than problem. That's our less than symbol, so I'm going to shade below. Turn the page. No? Question? Turn the page. We're going to do 6 of these and then some practice.
6.
These are going to go pretty fast. Y is greater than or equal to 1/3 x plus 4.
I don't know.
4.
Okay, so first of all, let's get our line.
1 over 3.
I'm going to start at 4, my y-intercept. My slope tells me to do what? Up 1 over 3. Up 1 over 3, don't connect them yet, though. Up 1 over 3. Up 1 over 1, 2, 3.
That's less than 3.
Hold on a moment. Should I use a solid line or a dashed line? Because it was greater than or equal to? Solid line here. Yes. Yep. Solid line. Now I need to do some shading. Pedro. Because it's greater than, I'm going to shade above it. So I'm going to go here, and I'm going to shade above. That's it.
Oh, God.
That's so different.
Not a big deal. Just a couple things we need to remember with these.
Is it okay if my shading's outside the box?
Outside the box, sure, but keep it above the line, though. Do you see how that worked? Y is less than negative 3/4 x plus 5. When you drew your line, should it be solid or dashed? Do it. Should be dashed. Draw the line. Maybe don't shade yet. Let's just get the line in there. Just to make sure the line is good. And then if it's good, we'll do the shading. Negative slope, yeah. Down 3 over 4, down 3 over 4. Shane, I have not. But I also think that you just made a solid line, and I think it needs to be a dash line.
No, I need the dash. It's solid and dash.
So I'm going to go do a dash line over here. Kind of like that. One point, because the line tells you, do we care about the points on the line or not? If it's dashed, we don't care about them. If it's solid, those are solutions. So that would be 1 point. Now, above or below? Below. I'm going to start on my line. I'm going to do everything below it. Because this was a less than problem. Less than means below. That's how I'm deciding that. Let's try this. You need to sign out. Get out your Chromebook, please, and sign out. Or you're not leaving.
You do
y is less than or equal to negative 5x. Solid or dashed? Which one? Solid. Graph a solid line and stop. What's your y-intercept? 0. Down 5 over 1. Down 5 over 1. We already said solid line, so solid line there. Yes? Shade above or shade below? Below. Does that mean here or here? First or second option? First. I'm going to shade over here. And it's going to look something like that. Did you see what I'm doing, Jonathan? One piece that's a little more involved, but this is the basic idea. This is not a terrible thing. Try 4. I think, enough points to make your line. That's all that I really care about. What's your slope, by the way? 1. 1 over 1. What was that? It is a dash line. Because isn't the number before the x a 1? 1 over 1 is my slope. You're starting at 3. You're starting at that y-intercept over there. Where are you shading? Gonna look like this. You can get a whole lot on that one. Just enough to make sure it's a good looking line. That's all I really care about with those. What was that? Because it's a greater than problem. That's why I shaded above there. Greater than means more, so we're going to go above our line. That's done. Got to show you 2 more. We'll do some practice. And that'll be it. What was that? What do you mean by split block? Not right now. This is third period. Lunch is next period. Okay. Number 5. About 20 minutes. We're good. What is this? What is that? It's a horizontal line. If you have no x, just a y in the problem, that means it's going to be a horizontal line. Horizontal line at a height of 2. This was a less than problem. So where should so I made a dashed line over there, right? Dash because it's just less than. Brian, where am I going to shade? Below. There's definitely a below to this thing over here. I'm going to go do this. Got to show you one more. Last one in the notes. What sort of line is this going to be? Solid line. And how would I graph x equals -3? Vertical line. Vertical line. X equals vertical line over there. I'm going to do a vertical line at 3. It's going to look like that. This is the one where there's a problem because there's no above or below. But this is greater than. Where are the numbers greater than -3? To the left or to the right? This is the only time we're going to do left and right rather than up and down. It's going to look something like that. That's it.